Good morning, ladies and gentlemen. Let's go ahead and do this review. We'll start off with when two traveling waves meet, they interfere and pass through each other.
We saw that in the pulse lab that we did yesterday.
Yeah. Constructive interference. Same side makes bigger bumps. When two waves are coming towards each other, when they finally meet. Oh, wrong way. I thought I had something else on that side.
No.
Wrong way again. Okay. They're on the same side. When they finally meet, they make a bigger bump. They add algebraically, and then they move through each other.
Pass through each other. That's
right? And destructive interference on opposite sides. So you've got one wave coming this way, the other wave is coming this way, and when they come in, they can cancel each other out if they both are a positive one and a negative one.
Yeah.
Okay. Now one might be bigger, one a little smaller, but we still are gonna have some canceling out of some sort.
Yeah.
Okay, and then they move through each other. Makes a smaller bump or nothing. Okay, so standing waves happen when incoming waves interfere with reflected waves, right? So we've got a wave that comes in, we send another wave, this wave comes back here, now we've got some interference, they move through each other, and we've got some interference there. Now, when they interfere at just the right frequency, that's when we see our standing waves.
Yeah. When you send pulses, they travel from one side to the other, but a standing wave happens as those pulses that are going back and forth encounter each other and they interfere.
Okay, and we'll do some demonstrations with that a little bit later. Or we could do it now.
Okay.
All right, so let's see, there's a lot of practice here. So standing wave parts, we've got a node and an antinode.
You got to hit just the right frequency.
There it is.
All right. So there's the big bump, and what's happening is a pulse going that way and a crest meets a pulse coming this way, it's a crest, and it gets a constructive interference. And then on this side, it's got a trough going that way meets a trough coming this way, and so you get constructive interference.
And do y'all see those antinodes and nodes?
So this is a node right here, and that's where a crest going one way meets a trough coming the other way, cancel each other out.
You mean, node, sorry.
That's a node. So go ahead and stop. Stop sending pulses. And that node is at equilibrium.
Node, there's nothing there.
Clears the node on your face.
Yeah. Okay, so we're done there.
Yep.
Okay. And the antinode was the bumps. My hand is hard. Okay, what do these symbols mean? F is for?
Frequency.
Capital T is for?
Period. Time.
Mm-hmm. This little lambda.
Greek letter lambda is wavelength.
Lambda kind of looks like a little lamb, I guess. Okay, and then the capital A is for?
Amplitude.
Amplitude, okay. What could you not control about the waves in the slinky? From our lab in the very beginning, well, we could not control the velocity, right? How fast that wave was moving through the slinky, through the medium. What did you do to change the length of the waves that you made? What did you do to change the length of the waves?
How were we making waves? By moving your hand.
Now, when we say length, we mean like the wavelength.
Wavelength,
crest
right.
between crests, right?
Yeah.
And in order to change that, we move it a little faster,
Yeah.
or we move it a little slower.
Yep.
Right? Okay. A pulse is sent. Oh, we got a practice problem. A pulse is sent down the 8-meter slinky in the classroom. So the distance is 8 meters. And it comes back in 3.18 seconds. So it goes there and back. What is the speed of the pulse?
So the slinky here is 8 meters long. It goes down, it comes back in that much time. So 8 meters in that much time, it has to go down and back. That's like an echo, isn't it?
Yeah, so it's gonna be 16 meters total, right?
Well, it's times 2 because it has to go down and then come back.
Okay, it's kind of like an echo there, like we said. And we're trying to find the speed here.
Yeah, which
Which one are we
variable?
gonna
I
use?
mean, which equation?
Let's use this one right here. So speed equals d over t. Okay, where the distance is 16 meters. The time is 3.18 seconds. As you were reading that question to me, I was like, it goes down and back, but we only have the distance down. We're definitely gonna have to multiply. Okay, so 16 divided by 3.18, and we get 5. I'm just gonna call it 5. 5 meters per second.
About 5 meters per second.
Okay.
Sweet.
Mr. Boykin sends waves at a frequency of 3.45 cycles per second.
So that means in 1 second I'm doing 3.45 cycles. That's going to be like this. Cool.
Cycles per second. And then what are we trying to find here?
The period of the wave.
Oh, this is the easy one. I like it. So whenever we're trying to find the period, we just do 1 over the frequency of the period. We just
They're
flip-flop
inverse of each other.
For some reason, I cannot speak about this equation lately. Okay, so 1 over. So we want the period, right?
Yeah.
So we got to flip-flop those. Okay, so the period equals 1 over the frequency, which is 3.45 cycles per second. Okay, so 1 divided by 3.45, and I get 0.28. I'm gonna call it 0.29.
0.29
And I'm gonna go ahead and flip those.
seconds per cycle.
Cycle.
Okay, now in order to get the wavelength, we're going to have the velocity. What was that velocity? It was about 5 meters per second.
From the previous problem.
I think it's still in the calculator.
Yeah, it was. Oh yeah, it was 5 right there. Okay.
So the velocity was 5 meters per second.
Velocity equals 5 meters per second. What is it asking here? It wants
What's
to know
the
length of-
wavelength?
The length of the wave. The wavelength.
Which one do you
Okay.
want to use?
Well, okay, so we're given the frequency. Let's use this one.
All
It
right.
can
So
be
how do you
calculated
solve
here,
that
but-
how do you solve that for wavelength?
Okay, so we've got V equals wavelength times the frequency, right?
Yeah.
I want this guy. I'm just gonna divide by the frequency. Cancel out. The wavelength is gonna equal the velocity, which we calculated before, 5 meters per second, divided by the frequency, which is 3.45. 3.45 cycles per second. Now, you could technically use period, but we rounded this, and if for whatever reason we got that wrong, then we would get this answer wrong. So 5 divided by 3.45, and I get 1.45 meters.
So that's about 1.45 meters.
Yeah. And just so also if you did use this guy right here, which again I just wouldn't because you could get it wrong, then you would just do TV, right?
Yeah.
And so if you did that, if you were thinking that, you're not wrong. Okay. What conditions produce constructive interference? What conditions? So
Well,
let's think about the wave parts.
What does constructive mean?
Well, constructive is when you have a crest meeting a crest, or when you have a trough meeting a trough, right?
That's right. You have
And
the same
so-
wave parts meeting, they
Yeah.
add together.
So those are our conditions, either a crest and a crest, or a trough and a trough.
Yeah.
Now, how about for destructive interference?
Well, you have the opposite sides.
Right, yeah, crest and a trough meeting and either canceling each other out completely or in some way.
Yeah.
Okay, so what are the parts of a standing wave?
Well, there's the node where
Uh-huh.
there's no movement, and then there's antinodes, and that's where you've got big movement.
So what produces the node?
It's a type of interference.
Did we just talk about this?
We did.
It's got to be destructive, right?
Destructive
Right.
interference
Dis-
produces a node. They cancel each other out.
Yeah.
There's no movement at a node. See, it has the word no in it.
Okay, and what about for what produces an antinode.
And that's a big word. That must be the big bump.
The big bump.
What
okay?
kind of interference produces a big bump?
Either constructive plus, a crest plus a crest, constructive, well, it's going to be constructive interference.
Yes, ma'am.
Crest plus crest or trough plus trough. Boom. Okay. Oh, and we're done. Okay, so here's your homework. So chapter 14 review, all of those guys.
This is the stuff that's going to be on the quiz. Some of these are really short, really simple.
Yeah.
And you should be able to check with other people on the answers.
And you don't have to turn this in. You're just going to do them because it's going to help you prepare for the quiz.
All right.
All right?